name is Dino Omanovic. I'm an engineering lead at HighGraph. We're organizing this conference, and as I understand it, I'll be kicking off my track. So I hope you'll have lots of fun with all the talks we've organized and all the speakers we've gathered. I looked at the list, and there are quite a few exciting ones, and I hope mine will be as well. If you have any questions, please reach out to me via LinkedIn. I'm very responsive there. I don't have a Twitter, sadly, but you can still reach me. My talk's going to be about the decision process you have when you choose a GraphQL provider, a service, software as a service, and the trade-offs you need to be aware about. So I'm targeting people that have some experience with GraphQL maybe, and now are thinking about the requirements for their project or product when choosing such a service. And if you're starting to implement a GraphQL API as a service yourself, these are things that you will encounter as well. So hopefully that's helpful to you too. All right, let's start. So the thing with GraphQL is that it's just a specification for a language, right? So we have GraphQL. This means graph querying language. And it does define things like structure, types, and how to define those, and how to write queries. But what it does not define is the exact queries you're going to get, the querying operations that are going to be possible, because that is the implementation detail of the service providing a GraphQL API. And since every project has different needs, it's very important to understand your requirements so you don't get surprised down the road by some issue or other that blocks you from implementing a feature because your provider simply doesn't support it or requires a lot of work on your part. So thinking ahead can save you a lot of trouble and time, and I'm hopefully going to give you somewhat of a framework to think about these things. If you want to think about these things, it's important to understand the core of your problem. And since I'm coming from the Go ecosystem, I have a guy I follow. He's Bill Kennedy, great guy. So if you're developing Go, watch his talks. But there's a sentence that stuck with me. It's not like a major quote, but for me, it's important. Every problem you work on is a data transformation problem. It's obvious, really, if you think about it, especially in our domain with GraphQL. So every query is a request to transform your existing data into a response. But having this perspective helps you understand the problem domain better. And I'm going to split this analysis up into a few parts. We're going to look at the kind of data you have, so some aspects or a certain perspective on your data that will help you make good engineering decisions. Then we are going into the flow of your data, so where it's coming from, where it's going, and what this means for a GraphQL API. And last but not least, we'll be talking about the social aspect of your project, which is the people working with your data, right? So we're going to take a look at the different stakeholders that are interested in the data and the API. Starting with the first thing, we're going to think about our data. So what kind of data do we have? Different projects have different kinds of data. Of course, there's relational data. As a developer, probably you know what I mean. So you might have something like a customer relationship management, customer relation management system, and there you have lots of relations between your data. So usually you're going to query and fetch certain things in combination, or you want to use filters and stuff like this. Or you might have something like an app where you have a to-do list, and this to-do list is specific to one user, and you're just going to fetch this list all the time. So there you don't have many requirements for relations. This is important in many regards because this has implications on the features that you need, but also on the performance characteristics and consistency characteristics of the API you're working with. We see the two credit cards there. Data is not just connected in some way, but also has a transactional nature or not, right? So data changes for some applications really need to happen in combination. For example, money transfer, which we'll see, or it doesn't matter if there's some slight delay if a change comes in later, or maybe it's even not important that all changes come in. So understanding the constraints in which your data lives is very important. Now let's look at some GraphQL. That's why we're here, right? So, and all the providers, and since I'm biased, I'm working at HighGraph, right? I won't be telling you which provider to use, but I'm using a few examples from us, but also from other providers, and all of them are great. So I'm just giving you some hints. And all of the providers, there's an underlying technology. For us at HighGraph, we're based on PostgreSQL, right? So for us, it's very important to offer transactional guarantees and to make our relational operations easier. Since we're a content management system, and content usually is highly connected, at least to some degree, and you have high demands on the querying. So with some APIs, you see the underlying technology shine through. A good example of that is Hasura, here at the top. Oops, that was wrong. Sorry. Here at the top, you see Hasura, and they basically are a layer on top of a relational database. By now, I think they're also planning to support other kinds of databases, but for now, that's the way it is. And with them, you really see the direct mapping from database to GraphQL API, right? So there is distinct on where, limit, offset, order by, which all sounds awfully SQL-y to a certain degree, which is not bad. So their focus, of course, is on adding GraphQL to a database, and the database is your focus as a developer in that regard. For us, it's different. Our focus is not on providing a layer on top of the database that exists, but instead we want to provide an API for customers that don't want to care about this. And still, you see with us the underlying technology shine through, right? We're also using PostgreSQL, and there you see the possibilities to do deep queries, deep relational queries with applied filters that are also being combined to a certain degree. So we see where we want to fetch authors in this example, where we want to have the first name be one of Dino, Gijs, or Michael. And also we want the author one of the author's companies to be HighGraph. And then you can go deeper and fetch posts, also apply another filter. We only want posts that contain GraphQL in their content. And then for those posts, we want to get the co-authors. Maybe we need to know who collaborated on the posts an author wrote. And then it could be a union with an author or a company, and you could fetch those posts then as well. So we see that even with a relatively short query, we can go very deep into relational territory. And if you understand the underlying data, this is going to give you some context, what you can expect from performance for different operations. If the service is based on a document store, maybe some of these operations might be more expensive or would have different characteristics you need to be aware of. And with all relational data comes the question of consistency too, right? Especially in a world now with CDNs and distributed systems, requests coming in from all over the world, and Google ranking by performance or latency. It's very important to understand the trade-offs you get with consistency. What I mean with that is that different consistency guarantees will result in different behavior. So looking at our example that we have here, we are going to transfer some money between two accounts. There's Dino, which is me, and Bob, and those have a transaction going. So we're setting the balance of Dino with their account number, which is a fake account number, so don't try sending money to it. It's a test number that's, I think, blacklisted even. So we're setting my balance to 300 and Bob's balance to 200. All is good. We're sending that mutation, and the mutation will get the correct balances back. So it works, right? So sometime after in the app, the customer has their banking app or whatever, me, and I'm going to check my balance, and I see that my balance is still 200, which it was before. How could that be? Well, it seems that our API is eventually consistent. So this change is not going to immediately apply to all following requests, because we have some caching in between. We will have multiple nodes and so on. So it's very important to understand the nature of your data here, and if you require these guarantees, because with these guarantees also comes a cost. If we were to ensure that every following request in this API would return the right balance, this would mean that if we have a distributed caching network, before the mutation returns and responds back from the API, we would need to invalidate all of those caching nodes to make sure that they don't serve stale data, which results in a lot of overhead, which you might not need if your data is not transactional in nature. Let's say you have some, shopping list. Maybe you've used, I think from Google, the shopping list. And there you'll see when you start up the app, at some point, updates are coming in if you shared your shopping list with somebody else. It's not important that it happens right away, that same millisecond, when the person enters it, but it's important that it happens before you go to the register in the shop. So understanding the needs for your project will prevent you from having a big shocker moment down the line when you see that customers see wrong balances or transactions are not going through as you expect them to. And this context also defines how you want to interact with the data, right? So you understand the kind of data you have. Is it transactional? Is it deeply related? And what are my requirements on that? And now you need to think about where it's coming from and where you're moving the data. In GraphQL, we have three root operation types, and only one of those is mandatory or required. Queries are mandatory for a GraphQL API to provide, so you can fetch data. Mutations and subscriptions are optional, but I'm still going to talk about those because they are extremely important, especially mutations. For queries, it's very helpful to understand the maturity of the API you're dealing with. So we have an example from the official GraphQL specs or docs, where they have a best practices example for pagination. Pagination is a common problem in software when you're working with large amounts of data. And we see how a query could gain some maturity to cover multiple use cases. At the start, we have a model called hero, or a type called hero, that has a name and some friends, and those have a name as well. And our query could just be hero, name, friends, name. And then we would get a hero, and the example, it's R2D2 from Star Wars, and the R2D2's friends. Now, we don't know the amount of friends we're going to get back. We don't know if there are more friends, if we got all of them. That's a problem if we're trying to build an application. So we could start by implementing a way to add some limitations to that. The first step could be to add something like a first argument where you specify how many results you want to get back. This helps you with your expectations on the amount of data you're going to get, but still doesn't tell you if there are more friends, if you got all of them, how you can fetch the next friends, and so on. So for that, we need to provide some more data. And this data, sadly, or not sadly, but shouldn't belong inside of the thing, right? The friend doesn't, the friend type has a name. A friend doesn't have a page or a position necessarily, because that is meta information that you need for querying. It's not relevant to the data type itself. So what we would need to do, and what a common pattern in GraphQL APIs is to add something like an edge and a node type. The edge is something like the connection between your hero and his friends or her friends. And on this edge lives some data, right? One thing is that it's connected to a node, and this is our object and the friend. And the other thing is that there could be some meta information. In this case, it would be a cursor. So that's the third window we see at the top right. It could be a cursor. And this cursor could tell us the position in the pagination we're in. But again, this is not enough. Now we know maybe where we are. It could be a number, it could be an ID. But it doesn't help us to understand if we got all the friends. So now we can start adding meta information to this edge, and or getting meta information. And the common pattern is to have a page info object that has an end cursor, and the information, if there is a next page, has next page. And with that, you know what's the last cursor. Do I have a next page? And with this information, you can then feed in the cursor you got into an API with, in this example, after as an input argument, and continue from there until you don't have a next edge. And this solution is pretty nice because the cursor could be an ID, it could be a growing number. You don't care, you just pass in the cursor you got into the input parameter after, and you're good. And there you see, it's a trivial example that's used in a lot of APIs, but there you see a gradually maturing API. And for the features you need and the querying capabilities you need, you should understand how mature the provider is. Now, with the possibility to query this deeply, which is the main benefit of GraphQL, right? You can fetch everything with one request. There also comes a drawback. For the providers like us, there's a certain challenge in allowing arbitrary querying, because you could write quite the deep query to make this more concrete. Let's look at the way usually APIs limit usage. Usually you get rate limits, right? With a REST API or something, or SOAP API or whatever, you get some rate limits. This means you can send this many requests per second. And that's great if you know the shape of the data or the amount of work you need to do when fetching happens. But with GraphQL, you get an arbitrary request in, and the deeper it goes, the more work your system has to do. So instead, there are mechanisms to calculate the complexity of said query. And I'm using the GitHub API as an example because I think it's well known and a lot of people use it. And in the left window, we see a query that has a cost of 550. So how is that being calculated? We're fetching repositories. We're going to get the first 50 repositories. And here you see the pattern from the window before, right? So it's quite common with the edges. So we're fetching 50 repositories. And inside of these repositories, we get so Git repositories, we get the first 10 issues per repository. So what we have is 50 repositories, 50 nodes of repositories. And for each of those, we fetch 10 more nodes. So 50 repository nodes, and then 10 times 50 issue nodes, which results in 550. So that's a way for us to estimate the amount of documents we will need to fetch from our data source, be it SQL database or however else we're storing that as a provider. Now, let's expand the query a bit. At the right side, we see a query that fetches repositories, the same number of repositories, and then gets, for every repository, the top 20 pull requests and the top 20 issues. And then we're going to get the followers for each, we're going to get the followers. So if we multiply that, we see what happens real quickly. 50 repositories times 20 pull requests, and in there we even have comments. So 50 times 20 times 10 is 10,000. So just by fetching 50 repositories with 20 pull requests each and 10 comments each, we potentially get 10,000 results. And the same goes for the issues, where we get 20 and 10 again. And this also multiplies with the repository because we're getting pull requests and issues for every repository. So we have 20,000 complexity points just for the repositories. And the query doesn't look too crazy, right? But you still could get 20,000 results in one response, which is great for you as a consumer, but means that a GraphQL provider could be killed with just one request if they don't add any kind of limiting. So what we do is usually there are multiple approaches to this. One is the very generalistic approach we see here, where we just count the abstract nodes we would return. Other APIs might have different costs for different kinds of fields you fetch. Then the calculation is more complex. So let's say a string field would be more expensive than a number field for whatever reason. Then you could add a cost of 2, and then this would be an additional factor in the multiplication, and we could end up with a really complex calculation. So most providers end up with this more generalistic approach, and be prepared to see that. One thing to be aware of, that this could be by request or it could be something over time. And more advanced APIs will allow for complexity points over time. So you can decide between few queries with high complexity, deep nesting, or a lot of small, easy queries to still allow for the benefits of GraphQL, where you need to fetch a lot of stuff at once. So that's one of the things to be aware of with queries. Now for mutations, which are again optional to be GraphQL compliant. For mutations, there are multiple trade-offs to be aware of. Writing usually is a way heavier operation, and therefore you could write mutations in multiple ways. I've created an example based on posts, authors, and companies. And let's imagine you create a post for some blog, whatever, and then, but you need an author for that post. The author doesn't exist yet, so first you create an author, and the author needs a company that you want to connect to. So you first need to create a company. So you create a company, then you create the author, then you create a post, and maybe you want to create relations between those. This could result in 6 requests. I've simplified this to 3, so it fits on the slide. Now, imagine that one of these fails, right? Like the author fails, and then you can create a post, but you cannot connect the author. In this example, maybe it's not too bad, but if it's something with money or something that's transactional, you really, really want those things to happen in a blog or not at all, right? So check your provider. This is an example from us, but others do it in a similar fashion. Check if you can do it in a transactional way, right? It could either be multiple operations in a mutation. So in the mutation block, transactional create, in this case, would have a create post, then a create author, then a create company, all in the same block. Or it could be nested, an API that allows for some nesting in the mutation, like ours, where you create a post, give some data. That data contains an author, and there you give a create. That author then contains a company that you also create, and all the data for the types, and then everything gets created in one single block, one single transaction, and if something fails in between, then it gets rolled back. So you're sure that if it happens, it will all happen at once. But also this means the single mutation is going to take quite a while, right? It's touching multiple entities and creating connections between those. And this, for deeper nesting, this can be quite an expensive operation, especially if there's a lot of traffic happening. So for our to-do list or shopping list, it might be more interesting to just provide single mutations and then maybe retry. Maybe you can get a lot more throughput this way, and maybe your provider's specialized on this case instead to allow you for way more traffic instead of these guarantees. And some will allow you to decide. Maybe you'll have multiple endpoints to decide. Maybe there's a flag. Maybe there are different mutation operations you can use. Check that and see if you if it's enough for you. Oftentimes, it's not enough to just write a bunch of mutations to insert data, because GraphQL is great, but due to its dynamic nature, optimization becomes quite difficult. So inserting huge amounts of data via GraphQL oftentimes is not ideal. Still, it's possible. So let's look at Hasura. I like them, so I'm using their examples too. In Hasura, for example, with an author, they would have something like an insert author mutation that allows us to pass in an array of objects. And this way you could create batches and insert those batches and so on. And there will be some optimization when inserting a batch. But not all APIs do it like this. Some APIs might allow you to import a CSV file or a big JSON file that's structured in a certain way. Others would point you to the docs, where you can see maybe an SDK or a CLI tool that allows you to do batch mutations, and then they have some other protocol between this tool and the service. But before you are in a situation where you have lots of data for a migration from an existing service and realize that you can't get it in a reasonable amount of time, make sure that you test this beforehand. And also for service providers, it's a pretty good idea to offer some migration path. So just sending in a bunch of single mutations can result in you getting blocked very easily or performance being dragged down. So we've covered queries and mutations to some degree. The last thing we have subscriptions. I think those are less common to see in services. So because they are for very special use cases usually. So let's say we have a system where we create a post and we want to react when a new post gets created. Polling, which means just requesting the currently existing posts over and over, is very inefficient and will affect your API usage. So you might run out of your rate limit or querying complexity limit really fast if you just poll every second to see if there's a new post. So we have two things or multiple approaches to tackle that, and you should understand the approach or the solution your provider offers. One thing is subscriptions, where you listen on changes, and with these changes, you would then get notified via streaming if a post gets created. The drawback here is that you have a long-running connection open between the GraphQL server and your service, serverless function, I don't know, whatever. So the long-running connection could be fine, could be a problem, you don't know. Depends on the use case, or I don't. The other possibility that's employed oftentimes is webhooks. We support this, for example, where you define a URL you want to get notified at, and then you get a HTTP request with some payload there that you can then react on. This sends multiple requests, which has some kind of overhead, but then again also doesn't have a long-running connection. So both approaches are fine, I think, and depending on your use case, one is better than the other. If you're creating a real-time chat system, probably subscriptions are better. If you just want to update or trigger some site generation, a webhook might be totally fine. We've looked at the kinds of data we have. We've looked at certain interactions this data has with the outside world. But at some point, people need to work with our data. So we've understood how our data is structured, what are the dependencies, what are my transactional requirements, consistency requirements, performance requirements. I understand how to get it in, how to connect it to other stuff, but this all lives in a vacuum until I look at my other stakeholders in the project. And I think one of the main reasons to use GraphQL is to allow for flexibility of different stakeholders, and with stakeholders, I mean also developers, right? So to allow for flexibility without the need for synchronization. So instead of having to just hack on some middleware glue service that just offers a REST API, and for every front-end requirement, you would need to create a code change. As a backend developer, for example, GraphQL allows you to skip the step altogether. But not all GraphQL APIs are equal in that regard, right? Some focus more on the experience for the backend developer. Let's say you just put something over your existing service, REST service, and expose it as GraphQL, or you put something over your existing database and expose it as GraphQL. Then the schema, GraphQL schema, is going to be defined by the database schema, for example. And since not all paradigms map exactly to the way, for example, front-end developers develop, this can become an issue. One example for that are unions. Unions are very useful, especially for front-end developers and app developers, maybe working with TypeScript, because in TypeScript you have the concept of type unions, right? We see a post author here. That's a union between author and company, because maybe in a post we just want to name the company as the author, not a specific name. And if you don't have unions on your GraphQL API, you need to construct some weird workarounds where you need to fetch in very awkward ways. So make sure that the provider you choose maps to the requirements of your stakeholder. So if you're a backend guy providing an API, wanting to provide an API for your front-end developers, probably they will be very happy to have these kinds of unions. Same goes for support for common patterns and frameworks. One thing we talked about are these edges. An extension of this is React Relay. Lots of React developers use it, and it allows you to do effortless pagination that really fits in with the whole component concept React has. And not all GraphQL APIs support this relay approach, and it is really important though. So make sure, if you're a very front-end heavy company, let's say you're a web agency, you want to make sure that your front-end developers can really work with the API. On the other hand, if you're a backend integration shop working with lots of data and you need to provide a GraphQL API for some reason or other, you have some other interests, right? So you're wondering, can I easily integrate my API or data? We've talked about this a bit with the mutations and the bulk import, but that's not all. Maybe you have existing services that you don't want to migrate data from, but you want to ask those for their actual live, their current live data, right? So your GraphQL provider could implement some sort of proxying or gateway capabilities. For us, the feature is called remote fields. For, I think Azure calls it remote sources. I think Supabase is something similar, where you can fetch another API, REST or GraphQL, and integrate it into your GraphQL schema. So you still have one request from the top and everything else gets fetched from there. Or you want to have your service, this service integrated into your existing gateway, if you have something like that. Right now, the currently reigning standard or spec is the Apollo Federation 2 spec. You see a short snippet there. This is the stuff that you need in the GraphQL schema to be compliant. And it allows you to interweave GraphQL schemas. So an author type could live in a service, a post type could live in another service, and the author type could still have a posts field. And because it's marked as with this directive external, you would know that it lives in another service. And all of these directives have a meaning, like key will define a primary key, so we know with which ID we can fetch in another service and so on. Currently, there is some effort going on, I think, in the GraphQL working group to define a federation standard. So we're living in quite exciting times, and hopefully soon we can just overlay all of our GraphQL APIs and just fetch once, really. And, oh, okay, I'm really close to being finished. So I'm going to end with a short checklist for you that you can take and just check. Ask yourself, how deep can I query this API? Does it satisfy my needs? Are the consistency guarantees good for me? Will it even perform if I scale? Do the filtering, sorting, searching tools suffice? Is the mutation operation powerful enough for my use case? Is the user experience good enough for my editors, content creators, and also the developer experience good enough for my developers, even third-party developers? And can I integrate my existing data? I hope that was helpful to you. Thank you for joining. I hope it was interesting. And if you have any questions, please reach out. Have a nice day. Bye.